The Dynamic Learning Maps, or DLM, alternate assessment system is designed to more validly measure what students with the most significant cognitive disabilities know and can do. This module describes effective mathematical teaching practices for students with the most significant cognitive disabilities who will complete the alternate assessment. This module is one in a series of modules that support educators in their efforts to teach and assess. This training is part of the professional development efforts of the DLM Consortium. When teaching mathematics, educators must have a clear understanding of the content they are teaching and how students learn and progress across grades. Educators must be intentional in their instruction so students can work at higher levels of mathematical thinking. Educators must also be skilled at instructional practices that develop mathematical thinking. For example, they must provide instruction that engages students in meaningful learning through individual and group experiences and promote the ability to make sense of concepts. Throughout this module, we will discuss 8 instructional practices that are effective for teaching mathematics in general education classrooms and how they can be applied to instruction for students with the most significant cognitive disabilities. The 8 practices are used individually and in combination within and across lessons based on the educator's purpose for instruction. They help create classrooms that encourage thinking and interacting. Providing a correct response is important for assessment, but when teaching, we want to help our students learn how to think and problem solve. The 8 practices encourage students to share information they think they know or information they think is accurate. These practices provide students with the freedom to take chances as they work to figure out mathematical concepts. The 8 practices are: implement tasks that promote reasoning and problem solving, elicit and use evidence of student thinking, establish goals to focus student learning, support students' productive struggle in learning mathematics, facilitate meaningful mathematical discourse, ask purposeful questions, use and connect mathematical representations, and finally, build procedural fluency from conceptual understanding. These practices emphasize learning and applying knowledge, interaction, collaboration, and ongoing comprehensive instruction. As we think about the application of these practices, we must consider that students with the most significant cognitive disabilities may have accompanying motor, sensory, or communication challenges that can make it difficult for them to engage in one or more of these practices. How can we, as educators, help all our students engage in instruction in a manner that allows them to learn and apply increasingly complex math knowledge and skills? Let's consider the first 2 practices: implement tasks that promote reasoning and problem solving, and elicit and use evidence of student thinking. These 2 practices require educators to offer lessons that provide as much variety as possible. We know from both research and experience that students with the most significant cognitive disabilities benefit from repetition, but the type of repetition impacts the depth of student learning. When educators instruct using repetition with variety, students receive multiple opportunities to work on a target goal in different ways. This promotes thinking and problem solving. Rather than only memorizing or recognizing information, repetition with variety requires students to think at deeper levels because information is used in slightly different ways or for different purposes. Repetition with variety should not be confused with more common forms of repetition through which the same information is presented in the same way until students demonstrate mastery. Students with the most significant cognitive disabilities who are taught using repetition without variety typically have trouble generalizing skills they master to other settings or using the skills in a flexible manner. Repetition with variety is one key to ensuring that students with the most significant cognitive disabilities learn in ways that lead to the application of knowledge and skills in mathematics. Let's look at an example of implementing tasks that promote reasoning, problem solving, and student thinking. The video you are about to see presents 2 lessons on place value using different models of 10 to encourage students to think about the number of items represented. The teacher uses several practices that promote reasoning and problem solving. Watch as she activates background knowledge, connects existing knowledge of counting by ones to counting by groups of 10, and uses repetition with variety by providing multiple lessons with different models of 10. Prior to teaching the lesson, this teacher started with a blank 10 frame in one lesson and no frogs on the log in another. She used the student's knowledge of counting by ones to fill the 10 frame and to fill the log. This clip demonstrates what happens next. Note that the students do not demonstrate mastery as this knowledge and these skills are just being introduced, but the practices are clear. Let's watch the teacher in action.
Puppies.
Okay, ready?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
There's 10. And so I have one whole box of 10 filled up. How many do I have outside of here? Let's count.
However,
1,
2,
2,
3
3. I have 3 that aren't in anything.
seconds.
So I have
Keyboard.
one set of 10s and 3 bunnies left over. Okay, so everybody has one full set of frogs on a log. One set of 10. Do you have any extra ones left over, Sarah? Do you have any extra ones left over? How many? Okay. Find 3, please. Where's 3? Sarah, take the number. Thank you. Take it. Take 3. Take it. Good. What's our number? What's the number? Okay. 10, 11, 13. 13. So 13 has one set of 10 and 3 ones in it. Nice job.
As you saw in the video, the student did not demonstrate cardinality of 3, the understanding that the last number name said tells the number of objects counted, but in the context of learning that's okay. Over time, this student will have multiple opportunities to apply their knowledge of counting by ones in different ways, and the teacher will elicit evidence of student thinking and understanding to guide instruction as students make thoughtful attempts and respond to her informative feedback. Pause for Activity 1. In addition to providing tasks that engage students in reasoning and problem solving, educators and students must have a clear understanding of the purpose of all instructional activities. Establishing goals to focus learning means you know what you are trying to teach and why it's important. Educators need to understand why they are targeting the things they teach and how that will help their students develop valuable knowledge, skills, and understandings. Stating the purpose or the goal of a lesson can serve to focus students and gain their attention. When students understand the purpose of a task, they are more likely to persist in their efforts to complete it. As students, most, if not all, of us have likely asked the question, "Why do I have to do this?" as we struggle to complete the task. All too often, students with the most significant cognitive disabilities are completing a task for the sole purpose of earning an external reward or participating in a favorite activity when they are done. Working for the reward keeps students from focusing on the important components of the task or activity. If students with the most significant cognitive disabilities are going to be successful in learning mathematical concepts, we must refocus our efforts on helping them understand what we are asking them to do and why we are asking them to do it. Another key question to ask from the educator's perspective is, do my students already know this information? If the answer is yes, then we should be connecting new information to this old information. If the answer is no, we should then consider whether or not students have known concepts or skills that we can connect to this new information. Let's watch a small portion of this video on place value again. Think about what the teacher could have said before the lesson started to help students know what they will be thinking about.
Oh, looks like everybody filled up their log. Okay, let's figure this out. Oh, Sarah. So Joshua, Josh, we're listening. Ready? Yeah, okay. So everybody has one full set of frogs on a log. One set of 10. Do you have any extra ones left over, Sarah? Do you have any extra ones left over?
She might have said something like, "Today we are going to count to see how many groups of 10 we have and how many ones are left over." When you state the goal or purpose of a lesson, use simple language that is clear and concise. In special education, in order to organize and make learning easier for students, we have the tendency to break activities or tasks down into discrete steps through task analysis. However, this practice may limit students from developing a full understanding of mathematical concepts. For example, we have taught many students to rote count 1 through 10, and we have them practice the skill devoid of the context of one-to-one correspondence. As a result, students learn to repeat or indicate a series of words or numerals when given a specific prompt, but have no idea that those words represent quantities. State standards across the country require that we teach understanding of both conceptual and procedural knowledge and skills that go well beyond these rote understandings. One important reason not to break learning down through task analysis is that it may eliminate opportunities for productive struggle in learning mathematics. There are several things educators can incorporate into lesson planning and instruction to support students with the most significant cognitive disabilities in their productive struggles to learn and communicate about mathematics. Repetition with variety is a key element of productive struggle in learning mathematics because it provides multiple opportunities to work on the target goal in different ways. Although not all lessons can build on familiar tasks and understandings, it is helpful to students when we can take the knowledge of a known concept or skill and link it to the learning of a new concept or skill. Using real-life contexts also helps students link the known to the unknown and supports active student engagement. For example, students are very familiar with educators and students coming and going out of the classroom. A teacher might set the purpose for the activity by clearly stating, "Today we are going to use addition and subtraction to see how many people are in our room. Let's count to see how many people we have right now." After counting and recording the number, the teacher might add, "Now tell me when someone comes or goes. We'll work together to add or subtract them from our total." Another important way to support productive struggle is through mathematical discourse. Educators and students talk out how one might think and problem solve. Discourse involves thinking aloud, which requires the educator or student to talk through details of the problem, decisions they make as they solve the problem, and the reasoning behind those decisions. Students with the most significant cognitive disabilities can benefit when educators slow down and articulate the problem-solving process. The pace gives students time to focus on the key parts of the problem. Thinking aloud also allows educators to model the language of mathematics. The following is a sample discourse between the teacher and students. Teacher: You all told me that 5 plus 2 does not equal 3 plus 4. How do you know? Student number 1: They are not the same. Teacher: What's not the same? Student number 1: This and this. The student points to 5 plus 2 and 3 plus 4. Teacher: Well, can anyone think of a way we check it? Look at the models on the wall. Can we use one of those? A teacher has pictures of a 10 frame, a number line, and linking cubes. Student number 2: I want that one. Teacher: You want the 10 frame. Does anyone else want to use a different model? Student number 3: I want that. Teacher: You want the linking cubes. The discourse would continue with the teacher asking questions to elicit student thinking and modeling mathematical language when needed. Many students with the most significant cognitive disabilities also have complex communication needs that can make it challenging for them to engage in mathematical discourse. When students have augmentative and alternative communication devices, educators should model ways that students can use their existing systems to engage in mathematical discourse. When students do not have augmentative and alternative communication devices, you can use DLM core vocabulary supports as a starting place. Educators will model mathematical discourse using the core. For example, the educator can provide a think aloud model for determining if two sides of an equation are equal in value. Using the equation 5 plus 2 equals 3 plus 4, the educator may say, Today we are going to use two 10 frames to help us find out if we have the same amount on each side of the equal sign. We have to decide if they are the same or different amounts. Remember, this sign means equal or the same amount. First, let's find out how many we have on each side. I'm going to start on this side of the equation, 5 plus 2, and count out 5 circles, 1, 2, 3, 4, 5, and put them on the 10 frame. Next, I'm going to add 2 more and put them on the 10 frame, 1, 2. Let's count to see how many we have in all. Each time the educator says a word that is on a student's communication system, you can model their use on the system while speaking the word. Another way to support mathematical discourse is to offer response options. Sometimes, especially when working on a new type of lesson or activity, it is too difficult for students to generate a response. Educators can get the discussion started by offering a few plausible response options, asking each student to select the one they think is best, and then discussing what is correct about each student's selection. You can also get students to comment on another student's response by asking them if they agree, disagree, or are unsure. Finally, from both research and experience, we know that students with the most significant cognitive disabilities often struggle with activity demands in various ways. New tasks and new concepts place high demands on students across cognitive, communication, motor, and sensory systems. All of these demands at once can make it difficult for a student to attend to the key features of a lesson. Repetition with variety is one way to address these demands. For example, educators might help students address the cognitive demands of a new activity or concept by providing easy ways for students to communicate while minimizing motor and sensory demands. As students gain experience with the concept through various activities, communication demands might be increased with selected responses replaced with greater expectations for discourse. Over time, motor and sensory demands may be increased as students are asked to show their understandings by building models. As the concept is repeatedly addressed in varied activities, the goal is to balance the demands so that students can focus on building knowledge, skills, and understandings. As educators engage students with the most significant cognitive disabilities in discussions, point out the value of their contributions and encourage them to expand on those contributions. Posing purposeful questions is helpful. Purposeful questions encourage thinking and expansion of ideas. Purposeful questions are designed to elicit information about what students think or know about the topic at hand without eliciting specific responses. For example, while studying a bar graph depicting how many students like movies or video games, the educator might start by asking students to tell what they think they know about the graph while saying the word what and pointing to it on the student's communication system. This is obviously a very open-ended request. If students have trouble getting started, educators might then point to the bars and say the word what. Then you would continue to probe asking questions such as more, not more, or more like, not like. This will help students realize that they actually do know some things about the graph you are studying. Representations are useful in all areas of mathematics because they help students develop, share, and remember their mathematical thoughts. There are many types of mathematical representations, such as number sentences, displays of manipulative materials, 10 frames, and graphs. Regardless of the form, representations can enhance students' communication, reasoning, and problem solving abilities. They also help students make connections among ideas. In general, mathematical representations help students learn new concepts and procedures. There are three forms of representations: concrete, pictorial, and symbolic. Educators need to think about how these forms of representation might be integrated into various lessons. Educators help students develop a conceptual understanding by linking concrete understandings to pictorial and symbolic forms. For example, educators can model the pictorial or symbolic form while the student is working with concrete items. So the student counts out 5 manipulatives or counts the 5 children in the picture, and the teacher shows the numeral 5. Students with the most significant cognitive disabilities should be exposed to all three forms throughout their instructional activities. When concrete, pictorial, and symbolic representations are integrated, they blend conceptual and procedural understandings in a structured way so that students learn the what and the how of a concept. In order to build procedural fluency from conceptual understanding, students with the most significant cognitive disabilities will need highly contextualized experiences with the math concepts. Educators will need to know the math concepts well enough that they notice any misconceptions students may have about the concept and adjust their instruction to provide students additional experiences with it. Educators will also need to be very thoughtful in their selection of the vocabulary they use so that students can build the language they need to describe their own mathematical thinking. Once students begin to develop an understanding of a concept, then educators can carefully examine and extend their understanding by focusing their attention on looking for patterns and making use of structure, looking for the connections between concepts, helping them use mathematical language and symbols, and using representations and tools strategically for the purpose of developing deeper levels of understanding of mathematical ideas, strategies, and representations. Finally, educators want to give students time to practice their understandings. This means we need to teach a concept and continue to apply it and use it across the course of the year in contextualized problem solving situations, not through repetition of the same activity. Pause for activity number 2. All of this may seem like a lot to accomplish during instruction for students with the most significant cognitive disabilities, but it all culminates in conceptually focused instruction. These practices provide us a way to think about comprehensive instruction that focuses on the application of knowledge, skills, and understandings rather than a few isolated math skills. When educators are planning for instruction, the mathematics practices can help guide planning. Specifically, educators need to ask, what are my learning goals for the lesson and the unit? What tasks will support the concept? What representations support the concept? How will I support student communication? What math language is needed? What questions will I ask? Does my lesson focus on the concept? Does my lesson extend conceptual understanding? How will students demonstrate their thinking? And finally, how can I use student thinking to inform my instruction? Thank you for participating in today's module. For more information on the DLM Alternate Assessment System, please go to dynamiclearningmaps.org. If you would like to view other professional development modules or access professional development resources, please go to dlmpd.com.